Salut! Studio channel is focused on virtual physics lab. Virtual physics lab is an artificial satellite, artificial space station, satellite that revolve around the Earth, and this one is Earth's space mass of that is 14 billion space station mass that relate with the artificial satellite, that much bigger. So this artificial satellite here, the planet, our planet, that the Earth, and our moon that is much less mass with relate with the Earth's. Okay, this is a revolving path of the moon that rotating about the orbit of the moon within 28 days to complete one revolution. Okay, the moon that revolve one revolution about the Earth's within 28 days. Here our star, that is sun, which is much greater, which is 333,000 Earth mass greater, and the mass of the Earth is 1. So the Earth's within the Earth's day, the Earth revolving around to complete one revolution in 365 days. Here it is, the sun within the Earth, the universal gravitational force between the Earth and the sun. Here, force of gravity, that G times m1 m2 over r square. R square means the radius between the center of the Earth to the center of the star or the sun. So there is a force between the attraction force between the two satellites, the two planets, that the star and the planet of the Earth, between them. Okay, Zalot Studio channel that is focused on simulation virtual physics lab. So Newton's law of universal gravitation. To simplify matters, we shall consider that the planets go around the sun in a circular orbit. There has to be a force pulling them towards the sun. So otherwise they would keep move in a straight line. Newton's universal gravitation law states that the mutual force attraction F that between the two masses m1 and m2 is directly proportional with the product of m1 and m2, and inversely proportional with the square of the radius or the distance between the two masses. So the magnitude of these forces is given by F is equals to, F means the Newton's universal gravitation force, or the law of universal gravitation force. F is G times m1 times m2 over r square, where G mean G, which is constant, 6.67 times 10 to the power of minus 11 Newton meter square per kilogram square, is called universal gravitational constant for all matter and everywhere. If the planet has a mass m, is traveling at a speed of v within a tangential velocity v, and follow the orbit of the radius r, the magnitude of the force, that the centripetal force straight towards the sun, has mv square over r. To finding the value of gravity, G mean gravity, at any distance above the surface of the Earth above the surface of the earth. The law of universal gravitation law tells us the force of a body act on the earth's gravity. So F mean universal gravitational force is equals to universal gravitational constant G times m1, mean mass of body 1 times mass of body 2 over r square. In this case, mass of body 1 mean mass of the earth over r square, mean the distance between the sun and the distance between the earth and the bodies. So G times m1 r1 is one of the gravitational potential times m2, where r is the distance between the distance between the center of the earth, the distance between m1, which means the distance between the center of the earth and the body of mass 1, mass 2, the body of mass 2, and mass 1 is the mass of the earth, and mass 2 is the mass of the bodies or the objects that far apart the surface of the earth. Newton's law, second law, states which is force is equals to mass times acceleration, where force is equals to mass times acceleration. Mass mean mass of bodies, acceleration, that is the gravity, the gravitational acceleration that is pulling down or pulling towards the center of the earth. So here m2g2 is Newton's second law, is equals with the universal gravitational force. All forces are equal, so g times m1 over r square times m2. Here g1 m1 g times m1 over r square mean the gravitational potential, the potential, where r is the distance between the center of the earth to the surface, that's capital R, and the height when the object is set. R is the radius of the earth, and h is the distance above the surface of the earth. Welcome back to the simulation, the Lord Studio channel. Okay, please subscribe this channel for to be increasing your knowledge about physics within simulation, virtual physics. Let's come to be the simulation part. This one is the star, which is the sun and the earth. So let's play it. Okay, here the gravitational force between the earth and the sun. Okay, here the gravitational force between the planet of the earth and the sun is F is equals to m1, mean mass of the sun, times m2, which is mass of the earth, times the constant, that is 6.67 times 10 to the power of minus 11 Newton meter square per kilogram square, over the square of the radius. Radius mean the distance between the earth and the sun from the center of each. Okay, this is a universal gravitational force. And here also what? The universal gravitational force between the earth and the sun, and let to be show the path of the earth's orbit, and the moon that revolving around the earth, the moon that revolving around the earth, that make a beautiful path, okay. This is, and the velocities of the earth, that is tangential velocities of the earth and tangential velocities of the moon here. Okay, this is the universal gravitational force. also the universal gravitational force between the moon and the earth. Okay, the force between the earth and between the moon. Here the mass of the moon m1 and mass of the earth m2. Between the two, that's the constant, universal constant, that's 6.67 times 10 to the power of minus 11 Newton meter square per kilogram square. It gives the radius between the moon and the earth, from the center of the earth to the center of the moon, that is r square, which make the force, universal gravitational force between the moon and the earth. And here the universal gravitational force between the earth and the satellites, that's the artificial satellites. Here the force from the earth, the attraction force from the earth to the satellite, and from the satellite to the earth, the attraction force between the two. So universal gravitational force F is equals to G times m1, that is mass of the earth, times mass of the satellite, over the distance between the satellite to the earth center. Okay, from here to here. So this is all about the universal gravitational force. Thank you. Here we is into scale. And this on the star, which is the sun, and here the planets. Okay, here also the star, that is the sun, that is much bigger, which is 333,000 times greater than the earth. And the universal gravitational force between the planet of the earth and the sun as much as here. And here, and also here, the moon with the planet of the earth, the force between them. And here just the scale. Here is the sun, the earth is as much, that is 14 billion space station, as much as that of the satellites.